10 inches a minute, baby. Just did it. 3/8 bit. That was terrifying. I'm Ryan Drapela with Cutting It Close, and I started 10 years ago with my first desktop CNC in my parents' animal barn, and I now own 6 CNCs worth over $400,000. And in today's video, I'm going to be running bits really fast to show you what they're capable of. So this is what you can expect to learn today in the order we're going to go about doing it. The first thing I'm going to talk about is Chipload and how it relates to feeds and speeds. Number 2, the common mistakes that I made and I had to learn the hard way over the last 10 years that I don't want to take 10 years for you to learn. Number 3, demo. So we're going to be cutting stuff on that shop saver back over there, and we're going to be cutting up to 1,000 inches a minute on different materials and different bits to really show you what bits are capable of. And number 4, the action items that I want you to take away so you can start implementing on your CNC journey to start saving time and money. So without further ado, let's go to number 1, Chipload, and why it's important. So what is Chipload and why is it important? Well, in my shop, we use over $25,000 worth of bits a year. So to me, a correct Chipload is going to increase that bit life. So instead of cutting out like 10 products, you're going to cut out 20 products with that exact same bit. So it's going to save you money, and your cut quality is going to go through the roof, which is going to allow you to sand a lot less. And I know all of y'all guys just love sanding all day long, hours at a time. So your cut quality is going to go up, your sanding time is going to go down, and that's also going to save you money. But you may still have the question, like, what the heck is Chipload? So let me explain that in the simplest way possible with a little bit of sawdust and this blackboard. So what is Chipload? Well, that sawdust right there is now a piece of wood, and my hand represents a bit. And what Chipload is the amount of material a bit needs to take off at a certain time to shed the heat away from the bit and out of the material due to friction and vibrations. So here's an example. My hand's cutting, and it takes away enough wood so this doesn't get hot. What most people do is they only take away a little bit of wood at a time, and what that does is causes friction like this. And just like if I rub my hands together like this, they're going to get hot. Well, that bit gets hundreds and hundreds of degrees hotter, and when a bit gets hot, it gets dull. And so what our friction and vibration is going to produce? Heat, if I can spell this right. And what does heat produce? Heat equals dull bits. So heat is bad for bits. The correct Chipload is going to get the heat away from the bit into the wood so the bit stays sharper longer so you can extend the life of your bit and have the best cut quality possible. So if Chipload is that simple, why does everybody make it so complicated? And there's 2 reasons for that. Reason number 1 is the quality of carbide. So if you're buying those really cheap Chinese bits, the carbide is going to be lesser quality and going to cause your bits to break a lot faster. And reason number 2 is each machine has different capabilities. Like a small desktop machine is not going to have the same capabilities as this massive $300,000 machine behind me. And so you're going to have slower feed rates on that machine. Now let's go over the 3 common mistakes that I see people make with their CNC bits. These are the 3 common mistakes that I see, and I have done all 3 of these myself, so I'm speaking from first-hand experience. Number 1 is running the bit too slow. You want to baby that bit, and you only want to run it at 50 inches a minute or 10 inches a minute because you don't want to break the bit or hurt the machine. Well, what you're doing is causing that friction, and you're cutting, instead of good, delicious chips, you have powder coming out, and that bit's getting hot, it's getting dull, it's hurting your machine and hurting your bit, so don't do it. Run it faster. Number 2 is not deep enough.
That's what she said.
What I mean by not deep enough is when I used to cut with a 1/4 inch bit, I only used to go like 25% of the diameter. So I used to go like a 1/16 of an inch down, 0.06 down, right, and not cut out much. The best rule of thumb to live by is whatever the diameter of the bit is should be your pass step. If you have a 1/4 inch bit, you should go down a 1/4 inch at a time if whatever your machining allows for it. If you have an 1/8 inch bit, go down an 1/8 inch at a time, 1/2 inch bit, 1/2 inch at a time, at a minimum. With some of my bits, and what you'll see later, I'll actually go down 3x the diameter, and the bit is still going to be okay. And number 3 is the machine rigidity. So once you see me run stuff on the machines behind me, you're going to want to go to your desktop CNC and run it at 400 inches a minute. Just know that that desktop CNC and the motors cannot handle and move that fast, or they're going to vibrate too much and cause the bit to get hot, and the machine's just not rigid enough. That's why this machine right here weighs over 21,000 pounds, and the one behind me weighs over 5,000 pounds, because they have to be rigid enough to hold the vibrations in from all that cutting action of the bit. So those are the 3 mistakes that I have made myself. Don't make them. Now let's go cut some stuff out on the CNC, baby. So the first thing we're going to be using is a 1/4 inch upcut, and all I'm going to do is do a simple pocket and a simple profile. But the cool thing about it is I'm going to run it at the correct chip load, and the pocket is going to run at 425 inches a minute and going to go down 3/8 of an inch. And then just to show you what a bit is really capable of, I'm going to be cutting all the way through this 3/4 inch plywood in one pass, going 250 inches a minute with a 1/4 inch compression bit. So I just want y'all to see what a 1/4 inch bit is really capable of. For those of you that may be running at like 50 inches a minute, I just want to show that. Yeah. So now that you've seen what a 1/4 inch bit is capable of, let's check out what a 3/8 bit is capable of. And I'm not gonna run this at the recommended feeds and speeds because I wanna just hog some material out. So we're gonna run it at 1,000 inches a minute doing a pocket, and then cut this 3/4 plywood in one pass at 1,000 inches a minute. And this is a 3/8 downcut bit. And if you want any of these bits, check out cscworkshop.com, any of these bits that I'm using in the video. And if you want a really good chip load calculator, I'm just finishing one up where it can be universal to all CNCs. You type in your CNC's horsepower, and it's gonna give you a recommended feed rate and RPM to run all your bits at. So the link is gonna be in the description for that. You can get on the email list, and we'll send you it as soon as I release it, which should be pretty soon. So let's get to running this 3/8 bit at 1,000 inches a minute. I've never ran it that fast before. That thing is moving. Inches a minute, baby! Just did it! 3/8 bit. That was terrifying. Look at that cut. Look at that cut quality. Isn't it absolutely crazy what those bits can handle? Now, these are the 4 things I want you to take away after witnessing that. Number 1, test your CNC. It's okay to run bits faster until they break and get a new one and test out what your machine can handle. It is okay. You just saw what I did back there. I was a little stressed, a little scared, but it's okay. Number 2, this is a little tweak that I didn't talk about yet, but it is really smart. So whenever you ramp into projects, never just plunge straight down, always ramp. And the length of the ramp should be twice the depth of the cut and should be half the feed rate. So if you're gonna ramp down and you're cutting down 1/4 inch deep, ramp at a 1/2 inch ramp length and do it half of whatever your feed rate is. That's my rule of thumb. That's what I use on all my commercial CNCs that you see right there. 3, depth. Depth should equal the diameter of the bit at a minimum for all wood projects. Plastics and different stuff like that has different tendencies, but for wood, depth equals diameter at a minimum. And number 4, just run the bits faster. Save yourself some time and money and understand your machine's capabilities. I hope this video helped, and remember, if you ain't cutting it close, you ain't cutting it right.